So when we look at example number 4 here, we're going to be looking at methane that reacts with oxygen to make carbon dioxide and water. So I give you the chemical formula for methane, and we're interacting with water, producing that of carbon dioxide, and we said water, H2O. So looking at those two things, first thing that we need to look at here is CH4 plus oxygen produces or yields CO2 plus H2O. When we're looking at this, we should notice that this is not going to be correct here. We need to have that as a diatomic. So looking at this, if we use our tallying method, we know that carbon, there's only 1 of. Hydrogens, we have 4 of. Oxygens, we have 2 of. And on the other side, carbons, I have 1 of. Oxygens, I have 3 of. And hydrogens, I have 2 of. So looking at this, we want to look at some type of multiple between those two things. So when we're looking at this, the biggest thing I would look at is the hydrogens here. So how can we make 2 hydrogens turn into 4? Well, by putting a coefficient of 2 here, let's see what happens. I have 2 hydrogens times 2, which is now going to give me 4. And I have 2 times 1, which gives me 2 plus 2 now gives me 4. Checking our answers here, I'm now looking at my oxygens. Quick fix here. Put a 2 in front of our oxygens, and now I have 2 O2s, changing this now to 4 oxygens all together. Now looking at conservation of mass, 1 carbon, 4 oxygens, 4 oxygens, 4 hydrogens, 4 hydrogens. Looking at our next example here, our next example that we have is between iron and water. So we're going to have iron, Fe, and oxygen, which we know is diatomic, so O2, producing Fe2O. So based off from this, we're going to look and see. So iron, Fe, I have 1 of. Oxygen, I have 2 of. Iron, I have 2 of. Oxygen, I have 1 of. So looking at this, how can I make these 2's become a possible answer? So when we're looking at this, I have 2 irons, 2 oxygens. So now what can I do? Well, let's try multiplying this by 2, thus resulting in 4 irons and 2 oxygens, sufficing for my oxygens here. So now these are equal. And to change my irons, all I have to do is put a coefficient of 4, and that turns to 4. So now I have 4 irons, 2 and 2, and everything checks out. Again, showing the law of conservation of matter. Okay, example number 6, we have copper. Plus we are going to have our hydrogen sulfate, H2SO4, producing or yielding our copper sulfate, plus H2O plus SO2. So quite a dramatic change from side to side. So since we got a lot of stuff to keep track of, again, using the tallying system, I have copper, I have hydrogen, I have sulfur, I have oxygen. So how many coppers do I have on this, on the reactant side? I have 1. Hydrogens, I have 2. Sulfurs, I have 1. Oxygens, I have 4. On the product side, coppers, I have 1. Hydrogens, I have 2. Oxygens, I actually have 3. So looking at this, we have to think about what is a change that I can have in order to offset my oxygens. Well, since I have a singular one here, and I know that it has to be an even number, why don't we just try doubling this? And by doubling this, now I'm going to end up with 4 hydrogens, 2 and 2 gives me 4 oxygens. So nice part about that is I already have taken care almost of my hydrogens, but I have to figure out another method. And I actually forgot about my sulfurs here. And sulfurs, I actually have 2 sulfurs there. And we know that those 2 are gonna possibly cancel out. So with my hydrogens, I need to get more hydrogens on the reactant side. So by doubling this, now let's check our answer. I have 2 and 2, which is now going to give me 4 hydrogens. 2 and 1, which is going to give me 2 sulfurs. And 2 and 4, which now in this case is going to give me 8 oxygens. So now looking at this with my oxygens, and I forgot my O here. So actually this number isn't even correct. I have 4 oxygens and 2 more, which is going to give me 6, plus 2 more is actually 8. So now that we check our answers, oxygens cancel each other out. Sulfurs are going to cancel each other out. Hydrogens are going to cancel each other out. And our coppers are going to cancel each other out, showing a nice balanced equation. Remember, as I did, make sure that you include all of the molecules that are found inside of the question. Last one that we have here is example number 7. Okay, I have calcium hydroxide. So calcium I know is Ca, and I have a hydroxide which I know is an OH group. Okay, plus, what's the next thing that I have? I'm going to have a phosphoric acid. So I had to look this one up. It's okay, H3PO4. Okay, which is going to produce or yield our calcium phosphate, which I used table E to figure out what a phosphate was. And also produces good old water. One way that you can write water, there's 2 different ways. We have H2O, but since I have a hydroxide, another way I can write water is HOH. So now when I'm keeping a tally on what I have and what I don't have, I can look at calcium. I can treat my polyatomic ions the same. So I can have OH, I can have PO4, and I can have H again. Looking at the product side, I still have my calcium, I have my OH, I have my PO4, and I have my H. So by separating this H and OH, it makes it much easier when trying to balance the equation, because now you're going to be looking at OH instead of just counting the H's, where you'd have to count those 2 separate. So looking at this, let's look at our quantities. I have 1 calcium, OH's I have 1, PO4's I have 1, and H's I have 3. On the product side, I have 1, I have 1, I have 1, and I have 1. So rough start to begin with. So looking at these, the thing that I'm going to focus the most on is these H's. Okay, so if I have 3 H's over here, and I need to have 3 H's over here, but I have to make sure that I have an even number for my multiple here. Because if I didn't have a multiple for my hydrogen, that's an even multiple, then I would offset with this. So, way that we can approach this. One of the ways that I would approach this problem is I would actually first change this hydrogen over here. I don't like that uneven number, so I'm going to actually make that a 2. So by doing that, I'm now going to have 6 hydrogens and 2 PO4. So I'm just going to put parentheses around here to show the separation of those. So how can I offset that? Well, if I have 6 hydrogens, one of the easiest ways to fix that is put a 6 there. And by doing so, now I have 6 of these, but how many OHs do I have? Well, I ended up now with 6. One of the things that we forgot to do is to make sure that our systems are balanced.